we would like to express our greatest thanks to our respected lecturer, Madam Asni Musa, for giving us the opportunity to deliver this presentation. In this video, my team and I will present about the application of basic analytical chemistry in our daily life. In this case, our team chose chapter 3, which is heating apparatus. So, what application on this topic related to our daily life? Before that, I will introduce you about heating apparatus. Heating apparatus are tools or machines used to apply heat during food processing. They are very important in food industry because many processes require heat, such as roasting, melting, drying, or sterilizing food products. There are several heating tools that we learn, such as muffler furnace, drying oven, water bath, burner oven. For more information, designated also a laboratory tools. It is a storage device for drying sample and preventing from reabsorption of moisture after oven drying. Meaning the desiccator is used to keep sample drying while they are cooling and before they are weighed, and in some cases to dry the wet sample. They are not only used in lab and factory but also in our daily life. For example, we heat production of cocoa powder. One common example is cocoa and chocolate production, where cocoa beans are roasted and dried to become cocoa powder and chocolate. These heating steps are important for taste, safety and quality, and also for chemical testing. This shows how analytical chemistry connect with real life users, industry and manufacturing. For this case, heating apparatus play a key role in transforming cocoa beans into the powder we use in chocolate drinks, cakes, and many food products. That's all about introduction. I will pass to my friend Anis.
Next, I will explain about theory of heating apparatus. Heating apparatus are tools that apply heating energy to substance. The heat causes physical or chemical changes such as drying, melting, sterilizing, or cooking. The process works through heat transfer, which is the movement of thermal energy from a hotter object to a cooler one. There are three main types of heat transfer. First is conduction, direct contact. Second is convection, fluid movement. And third is radiation, heat wave. Now, we move on to types of laboratory heating equipment. First, we have drying oven. A drying oven is used to dry samples prior to weighing. Well ventilated for uniform heating. The usual temperature employed is about 110 Celsius, but temperatures of 200 Celsius to 300 Celsius may be obtained. Next, we have furnace. A muffler furnace is used to ignite sample to high temperature, either to convert precipitates to a weigable form or to burn organic materials prior to inorganic analysis. Temperatures up to about 1200 Celsius. Third, we have water bath. Water bath used to incubate sample in water at a constant temperature over a long period of time. Most general laboratory water bath go from ambient up to 80 Celsius or 99 Celsius. Lastly, we have autoclave. Autoclave is a device used to sterilize equipment and material by using high pressure steam. The steam is heated to 121 Celsius under 15 psi of pressure for 15 to 30 minutes. The purpose of autoclave is to kill bacteria, virus, fungi, and spores.
First key step in cocoa processing. Here, cocoa beans are heated at temperatures between 120 to 150 degrees Celsius using a hot air oven. The purpose of this step is not just to enhance the aroma and flavor of the beans, but also to make them easier to grind and process further. From an analytical chemistry perspective, temperature control during roasting is crucial because it ensures reproducibility of flavor quality and prevents the degradation of volatile compounds, which are responsible for the bean's unique aroma. If the temperature is too high, this important flavor can be lost. Second, sterilizing part. In some factories, cocoa beans are sterilized using an autoclave. This device uses steam. steam under high pressure to kill harmful microorganisms, ensuring microbiological safety. For the analytical chemistry condition, gravimetric analysis can be applied before and after sterilization to monitor moisture content, ensuring no significant water loss that might affect bean quality. For third part is drying. After grinding, the cocoa paste is dried using a hot air oven, which is a common heating apparatus in both industries and analytical labs. The oven provides controlled heat to remove excess moisture from the cocoa paste, helping to prevent mold and spoilage. So for the in basic analytical chemistry, this drying process can be analyzed using gravimetric analysis because by measuring the mass before and after drying, we can determine the moisture content. Gas chromatography, which is mass spectrometry, can be used to detect any volatile compounds that are lost or formed due to heat exposure. This ensures that the drying process maintains both safety and flavor quality. So, the hot air oven doesn't just dry the cocoa, it also supports chemical analysis and product consistency. Last part, which is melting. In this step, cocoa, butter, and other ingredients like milk and sugar are gently melted using a water bath, a common heating apparatus in laboratories. The water bath ensures control and even heating, preventing the chocolate from burning. From a basic analytical chemistry perspective, this process involves a physical change, not a chemical one. The melting point of cocoa butter can be observed and measured to assess purity since pure substances have specific melting points. Any deviation can indicate the presence of impurities. Analytically monitoring the solid to liquid transition also helps maintain consistency in texture and quality of the final product. So, the water bath not only melts the ingredients, it also supports analytical chemistry quality control.
Daily life, let's talk about what we do at home. Melting chocolate in a double boiler instead of melting it directly over fire, we use water bath. This prevents the chocolate from burning and the result is a smooth creamy texture perfect for coating or dipping. Then toasting cocoa nib in the oven. When we toast nibs, the heat brings out a deeper richer cocoa flavor. This makes the chocolate taste more intense and delicious. Also, boiling cocoa for hot chocolates help kill bacteria. So not only is your drink yummy, but it's also safe to drink. Let's move to how heating is used in the cocoa industry. Okay, roasting cocoa beans in a hot air oven. This process gives the chocolate its signature flavor and at the same time kill harmful microbes. Next, water bath heating. This method is used to melt cocoa butter slowly. It keeps the texture soft and prevent the ingredient from separating. This is useful during mixing and molding. Here are some results that manufacturers look for. Moisture test after drying. Help cocoa reduce water content. Less moisture means longer shelf life, a better texture, so no one wants soggy chocolate, right? Also, next, sterility check after steam treatment. The product is checked because to make sure it's free from harmful bacteria. This is very important for food safety. Then melting cocoa butter with a proper will give a chocolate that beautiful glossy shine and smooth mix. That kind we love to see and eat. That's all about example of result. I will pass to my friend.
Lastly, for the conclusion, heating apparatus such as ovens, autoclave, and water bath play a crucial role in analytical chemistry and have wide-reaching applications in our daily life. At the household level, these tools mirror the functions of kitchen appliances like ovens, steamers, and electric kettles to demonstrate how fundamental laboratory concepts are embedded in our daily routines. During industrial process, especially in cocoa and chocolate production, controlled heating is vital for key processes such as roasting cocoa beans to develop flavor, drying ingredients to remove moisture, melting chocolate for shaping and coating, and lastly, sterilizing equipment to ensure food safety. This application not only improve product quality and shelf life, but also enable accurate chemical analysis such as moisture content determination, fat melting point test, and microbial assessment. By using heating equipment, scientists and manufacturers ensure consistency, safety, and excellence in their products. Ultimately, the heating apparatus introduced in Chapter 3 are more than just academic tools. They are essential instruments that bridge scientific understanding with real-world impact in both personal and professional spheres.